Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I will be calculating the values for a DC parallel circuit from the Chapter 7 math handout, problem number 4. Parallel circuits. Didn't mean to say series. Alright, I will be taking my known values from the Chapter 7 math handout shown here, and you can go to your Canvas page and print a copy. I will leave a link in the video descriptions below. Also, I will leave a link there to print it out. Or you can just pause the video now and write them all down. Only 1 through 7 are on the Chapter 7 Canvas answer sheet assignment. So number 8 is not on that assignment, and we can do number 8 in class together. Or I will make a separate video showing how to solve number 8. Alright, so I got my values here, number 4. And I can see that I did not get all of my resistor values. I only got one resistor value and some other values. So this tells me that it's a random unknown when I look at it. The other document that I'm using is the series parallel rules. Right now we're working on this side with our parallel rules. And I clipped out the portion of the of the document with the rules for parallel on it. So I've already clipped that out and put it right here. So now we can get started. We look at our circuit here, and the first thing I'm going to do, understanding the rules for parallel circuits, shows me that voltage stays the same, so I can go ahead and fill in all of my voltages. And here's the steps. You should write these steps down as we go, or pause the video and write them all down at the end. Alright, so my first step is I filled in all of my voltage values. So my next step is going to be to find IT. So if I look at my Ohm's law wheel, and this is the first thing you should do when you get your scratch paper, is write down the Ohm's law wheel and the power formula wheel. Have that on your scratch paper. So I want to find IT. I look at my formula wheel. It shows me that if I cover up IT, it leaves V over R. So I'm going to take the V divided by the R to find the I. So what is my V? 108 volts over 90 ohms. V over R right here on the formula. I've got V over R in there. That's going to give me an I. I hit equals. I hit engineering, and it's 1.2 amps. Alright, I also see that I have P1 and I have V1. So with the power formula shown here, first he covers up the P, so that's V times I. If he's looking for I, though, when we cover up, oh, here's voltage, I'm sorry. Here he's looking for voltage. He covers up the voltage, and it's P over I. But if I'm looking for current and I cover up the current, it shows me that P divided by V would give me the current. So for I1, I do have the voltage and the power. So the P always goes on top in the power formula. So it's 10.8 divided by 108 volts. This gives me 100 milliamps. So now I have 100 milliamps and I have 200 milliamps. I'm still looking for I2. I don't have resistance, I don't have power, so I can't use the Ohm's law or power formula. But what I can do is I can take and subtract I1 and I3 from I2. If I subtract I1 and I3 from IT, it will give me I2. If I subtract I1 and I2 from IT, it will give me I2. And this is kind of a little formula I made up to express it a little bit more clearly. I2 is going to be equal to IT minus I1 plus I3. So I got 100 milliamps, let's say 1.2 amps minus 100 and 200 is 300 minus 300 times 10 to the negative 3 equals 900 milliamps. So I do a little fill in the blank thing there to find IT. I'm sorry, I mean to say I2. I did a little fill in the blank there to find I2, not IT. I misspoke, sorry. Okay, now that I have all of my currents, I can use Ohm's law to find my resistances. So R1 is going to be equal to V1 divided by I1. If I look at my formula sheet, if I cover up the R, it's equal to V divided by the I. If I've got the V and I've got the I can find the R. And I do have the V. It's 108 volts divided by 100 milliamps. And that gives me a resistance value of 1.08 K ohms. K ohms. All right, next for R2, I'm going to do 108 volts divided by, I'm going to change out the bottom only, the numerical value. I'll even leave the metric prefix in there. All right, so that would be 108 divided by 900 milliamps. It equals, that should be 120 ohms. And the next one, I take the 108 divided by 200 milliamps. So let's change this 900 to a 200. And that's 540 volts. All right, so we found all of our V's. The next step was to find I1. We found I1 using Ohm's law. Next, we found IT using this formula. IT was equal to, I'm sorry, I2. I keep saying IT. No. I2. We found I2 using the formula shown. After that, we found all of our resistors, and then after that, we found all of our, well, we're at that step now. We're going to find all of our powers. So PT is going to be equal to IT times VT. So I'm going to put my voltage in first, 108 times IT 1.2 equals 129.6 watts. P1 was given to us. Next we'll find P2, which is equal to 900 milliamps times 108 volts. So I got the 108 in there already. I'm just going to add my current, which is 900 milliamps times 108. So I got the 108 in there. 900 times 10 to the negative third gives me 97.2 watts. Finally, I'm going to do P3, which is the 108 volts times the 200 milliamps. So let me change this to 200 milliamps. That gives me 21.6 watts. All right, now that I've got all of my calculations made, you can see up here, these will be the problems on the Chapter 7 Math Handout Canvas Answer Sheet assignment on Canvas. So I'm looking for I2, R2, and P3. All right, I hope that helps you. Thank you, Mr. Fontenot.